In this example, I'd like to work out a substitution integration problem. This question came up on MyLab Math, and it was hinted already that you needed to use substitution. Sometimes you don't get that hint, right? But in this section, we knew it's all of the problems were using substitution. Another nice hint that came in with this example was a hint of what to use for U. We don't always get that hint also. So you want to be able to do this problem as if you didn't have any of those tips. And let's approach the problem from that standpoint if we didn't have any tips. So the first thing I would do is notice that there's not a way that I can do the integration because we have two things being multiplied and we have a radical. So there are a few problems here. It doesn't fall into one of our nice, neat formulas. And that is what would indicate to me that I'm going to need to use substitution. When I'm looking at what to substitute, what to use for U, I'm often going to go to what's on the inside. Oh, sorry, I keep moving the image rather than being able to highlight. So what I want to do is go inside a grouping symbol. For example, the radicand, what's under the radical, is often a good clue to this is what a good U might be. And it's okay if you try a U and it doesn't work, but let's try it. If we let U equal 2x squared plus 5x, that's the first step. Then the second step is to find the derivative of U. The derivative of U, and notice that there are x's in here, so our derivative is going to end with chaining, and so having dx. But our derivative of U would be 2 times 2 is 4, x to the 1 plus 5 integrated, or times dx, times the dx because of the chain rule. So if I rewrite this expression, I could have the square root, and then I'm going to put this 4x plus 5 dx together. But I could substitute in U, is this 2x squared plus 5x. I could substitute a U in for that, and then I can substitute, or you know what, while I'm here, I'm going to rewrite it as U to the 1/2. But then I can substitute this 4x plus 5 times dx is the du. So I have U to the 1/2 integrated over du. Now we've got something that falls nicely into our power rule. And so if I integrate U to the 1/2, I'd have U to the 1/2 plus 1. That's 1/2 plus 2 halves, or in other words, 3 halves, over 3 halves. But you know, a better way to write that would be to say we've got U to the 1/2 plus 2 halves is 3 halves over 3 times 2. Because when I do this divided by 3 halves, it's the same thing as multiplying by 2 over 3. So I have 2u to the 3 halves over 3. I'm going to rewrite that so that it has the radical. I'm going to get rid of the rational exponent. So I'd have u cubed and then square rooted. And I could simplify that to be 2u square root of u over 3. The last thing left to do is to substitute back for this 2x squared plus 5x in for u. So what that's going to look like is this. Two times 2x squared plus 5x times the square root of 2x squared plus 5x all over 3. And that's it. I hope that that example helps you. If you need further assistance with simplifying or with the substitution, please don't hesitate to let me know.